than or equal to -2. And when we write the range, of course, it's what our y values are. So I would rather have that written as y is greater than or equal to -2. All right, so what we're looking at here is -2 on my y-axis and everything above or greater than or equal to -2. So my range y is greater than or equal to -2. So moving into 12.5, homework lesson 12.5. This lesson is about the vertex and about the axis of symmetry. So we're being asked in number 1 to graph the quadratic functions. So today let's use our graphing calculator. And let's graph y is equal to x squared plus 2x minus 3. All right, so I don't have a very good window here. So let's try to change this, and let's go and see what happens when I just do a standard window. So it's not too bad. I think that this can help me in finding the vertex and drawing this parabola and finding some other key characteristics. So to help me with that, let's take a look at our table. So my first ordered pair is at -5, 12. That's up here off the graph somewhere. So let's try the next ordered pair. -4, 5. -3, 0. -2, -3. -1, -4. 0, -3. 1, 0. 2, 5. And then 3, 12. All right, so we're going to label the vertex. My vertex -1, -4. And then we're going to draw the axis of symmetry. So that would be the line, the vertical line that divides the parabola exactly right down the middle in half. So we usually denote that with a dotted line. And as with all vertical lines, we're going to name that by x equals, and since that passes through -1, we're going to call that line x equals -1. So my axis of symmetry is the equation x equals -1. Now, there are many ways of finding that axis of symmetry. One way is by graphing and visually looking at the graph to determine what line is a fold line, which goes right down the middle of the parabola. Another way of finding that line is by using the equation y equals -b divided by 2 times a. My value for b and my value for a will come from my original equation in standard form. So in standard form, what I remember in standard form, I have a to x right here. You know what? We're just going to write that as y equals ax squared plus bx plus b. So we can see I'm going to get my b value and where I'm going to get my a value from. So to write the equation of the axis of symmetry. I'm going to take out negative b and replace b with positive 2. And I'm going to take out a and replace that with positive 1. So I get negative 2 divided by positive 2, and then I get the equation x equals negative 1. Another way we can find the axis of symmetry is by averaging some symmetrical points. For example, I can average my two x-intercepts. So let me list them first. My first x-intercept is negative 3, 0. And my second x-intercept is 1, 0. And so like I do when I average test scores or average anything, I add the two values together. And in this case, I'm adding my two x values, negative 3 plus 1, and then dividing that in half, just like I would average two numbers. So that gives me negative 2 divided by 2, which is negative 1. So my axis of symmetry, x equals negative 1. So throughout this lesson, we can use any one of these methods to find the axis of symmetry. Number 2 says to write a function that represents the vertical motion described in each problem. So let's just write that function, that vertical motion function, h of t, as a model negative 16t squared plus b sub 0 times t plus h sub 0. Some just reminders. This represents my initial height. This represents my initial velocity. And t represents time in terms of seconds. So my function for number 2, catapult h of t. We have an initial height of 36 feet and an initial velocity of 82 feet per second. So my equation would be modeled with negative 16t squared, my initial height, my initial velocity, 32, and oops, I've got that backwards. Let's try that again. My initial velocity is 82 feet per second. And my initial height is 36. Number 4, we have to find the vertex, the axis of symmetry, and number 4 is another catapult, and we are given the function negative 16t squared plus 96t plus 32. So let's start with the vertex. Alright, so my window does not show the vertex of this parabola, so I need to change my window. Alright, so it's still not apparent what my vertex is. Alright. So in this problem, I'm looking for the maximum. So I went to second calculate, going down to maximum. And I'm going to enter my left bound. Enter my right bound. Enter a third time. maximum at 3, 176. Now what that means, although this problem is not asking me, it's saying at 3 seconds, my catapult, my pumpkin, is at 176 feet in the air. That's the highest point, the maximum. And then I also need to find the axis of symmetry. And since the vertex is at 3, 176, I notice my axis of symmetry is going to be x equals 3. The axis of symmetry has to go through the vertex. Number 6 is asking for the same two key characteristics, the vertex and the axis of symmetry. So let's go back and change our function. So I want to go back, and I forgot to put in my x value before I graphed it. All right, let's try that. All right, so what I notice is that the rocket is being launched at the ground at 0 seconds, 0 feet. And let's find the vertex or the maximum. So at 3.5 seconds, the rocket is 196 feet off the ground. And therefore, my axis of symmetry is x equals 3.5. Alright, it's asking me to find the axis of symmetry for each parabola. So I'm just going to draw a sketch of each of these. Let's take a look at number 8. So my x-intercepts are at -3 and +1. So what that means is my parabola will have a line or an axis of symmetry that will go right in between those 2 points. And so what I can see from my graph, that would be the line x equals -1. When we talk about taking these two x values and averaging those two, that would give me -2 divided by 2, or -1. Number 10, if I were to draw these 2 points on a parabola, I can sketch this at -4, 1, 2, 3, 4, 5, 6, 7, 8, and 2, 8. So if these are 2 symmetrical points, what we know is that the line of symmetry is going to go right in between these 2 points, equidistant. So we have to find the line that would be equidistant from both of those 2 points. So again, what I'm going to do is I'm going to take my two x values, -4 and 2, and average those together, and then divide by 2. So -2 divided by 2 is equal to -1. So again, my axis of symmetry, x equals -1. Number 12, there's a couple of ways we can find the vertex of this parabola. We've been graphing them and finding the maximum or the minimum. They give me a little extra clue here. It says that the axis of symmetry is 4. So here's what that means. Is my axis of symmetry is x equals 4, then I know for sure my vertex has to be 4 comma something. So if I want to find my missing y value that goes with x equals 4, I can do several things. But if I wanted to, I can just go ahead and plug in and find what f of 4 is. So in my equation, x squared, out comes x, and in goes 4. So 4 comma -9 is my vertex. Well, we can check that on a graphing calculator to confirm that that is indeed my minimum or my maximum, or the vertex of the parabola. Number 14. I think most of you feel very comfortable using a graphing calculator, and for most of us, we're visual learners. So let's go ahead and use a graphing calculator for number 14. Let's see if I can get just a little bit better window here. And if I want to take a look at the vertex, I can do calculate, my maximum, enter left bound, enter right bound. So my vertex is at 4 comma 36. Let's take a look if this looks like a reasonable answer. Well, if I take a look at my x-intercepts, it looks like it's at -2. Might have to find this one over here. But what I do notice is in this problem, they actually give me two symmetrical points. Let's take a look at -1, 11, and 9, 11. So I'm going to take an average of these two values. Since they provided those 2 points for me, gives me 8 divided by 2, which is equal to 4. So that confirms that my x value, my axis of symmetry, is x equals 4. And then what I can do from here is find what f of 4 is equal to. And what I'm hoping that it will be, f of 4 will be equal to 36. That's what I'm hoping. So the opposite of 4 squared plus 8 times 4 plus 20 is 16, and 16 plus 20 does equal 36. So there you have a couple of ways of finding the vertex. In number 16, we need to determine another point on each parabola. So let's sketch number 16, take a look at what it looks like. So what we know is the axis of symmetry is x equals negative 4. Let's try that again. All right, so my parabola has an axis of symmetry or a full line of x equals negative 4. Now, one of the points on the parabola is 0, 6. So if I were to plot 0, 6, 1, 2, 3, 4, 5, 6, somewhere up here. So what that means is I'm going to have another point that is symmetrical to this point and equidistant to my line of symmetry. So somewhere over here, I have a point that is equidistant from x equals negative 4. So from here to the left, if I go 4 to the left, if I continue going 4, I'm down here at negative 8. So my other point here is negative 8, comma, 6. And we can check this. We can take my point 0, comma 6, and I can average my two x values. And that gives me negative 8 divided by 2, which is negative 4. So it does check. Here's my axis of symmetry, x equals negative 4. And so I'm going to determine my other point to be negative 8, comma 6. All right, number 18, I'm going to use a graph. I think it's a little bit better. Again, I need to find another point. So we're going to start with the vertex at 3, comma, negative 1. So what I know is if this is my vertex, then my line of symmetry has to go through my vertex. Now, I don't know very much more about this parabola except that there is another point on this parabola at 4, negative 1. Sorry, at 4, positive 1, right here. So another point would be symmetrical to this point, which would be over on this side, the equidistance from the axis of symmetry. So that other point would be 2,